Good morning, dear students. Today we are going to start with a new topic in a pharmaceutical engineering, that is size reduction. So we will see the introductory part of size reduction, and later on in next subsequent lectures we will see the equipments which are used for size reduction. So this is the in short content what we are going to focus in today's video lecture. First introductory part of size reduction, later on the objectives of size reduction, which are the basic mechanisms of size reduction. This is very much important because majority of the time the question asked in the semester examination on mechanisms. And next is the factors which affect on the size reduction process. The factors affecting on size reduction process is also we have to understand in very much clear manner in order to see which factors affect on the size reduction. So these factors helps you to select the proper equipment for size reduction process. Also, you can better way come to know about the which are the characteristics of the material that affect on the size reduction process in the factors affecting on size reduction. One by one, we will see. So first important thing in introductory part, you must know the basics about the size reduction process. What is mean by size reduction? Size reduction is basically it is an process. What we do in this process, we convert a large size powder particles into small size powder particles. So simply large size powder particles are converted to small size powder particles with the help of size reduction process, and it is extensively utilized in a pharmaceutical industry. So we'll say with the help of diagrams you can better understand. So pharmaceutical industries utilize the powders, and these powders consist of powder particles which are irregular in shape, you can see. So these are irregular powder particles available at various sizes. So this is in short a diagrammatic overview of a single powder which consists of many powder particles, and these powder particles, this powder sample is polydisperse. Why this is known as polydisperse? Polydisperse, what as the name says, polydisperse. So it consists of many powder particles, and the size of the all powder particles is not the same. Size is not a same size. Means these are available in various size range. So that's why this is known as polydisperse powder sample. Why this is known as polydisperse? Polydisperse means it consists of many powder particles, and as you can see in the diagram, few powder particles are fine powder particles, few are coarse powder particles. So it is simply a polydisperse powder means it is simply a mixture of powder particles which consist of various size range. And these powder particles which are available at various size range, with the help of size reduction process, what we do in size reduction, simply in size reduction what we do in size reduction process, we break these powder particles. We break these powder particles to get again fine powder particles like this. So simply in size reduction what we do, we break the powder particles to get a fine powder particles like this. So again you can see in the diagram here, with the help of size reduction, just we have converted a coarse powder particles into a small size powder particles. But still, this powder sample which we get, this powder sample is polydisperse, because as you can see in the diagram, this powder sample consists of mixture of powder particles, and the size is not the same. It is available in the form of various size range. So again, this is a polydisperse powder sample. So why we have discussed this? Through size reduction, through size reduction process, you will get a polydisperse sample. You will not get monodisperse sample. Size reduction will gives you polydisperse powder sample. Polydisperse means powder particles are available in various size range. You will not get monodisperse powder. Monodisperse means all powder particles have same size. So through size reduction, you will get polydisperse. For monodisperse sample, we require one more process which is known as size separation. Through size separation, what we do? We separate out the powder particles according to size. Here you can see this powder sample, and this powder sample I have subjected to size separation process, And through size separation process, here the powder particles I have separated according to size like this. So now this powder sample is monodisperse because you can see in the diagram all powder particles have same size. So in order to get a monodisperse powder sample, I require two processes. First process is the size reduction process and next process is the size separation process. So size reduction simply break, sorry, size reduction simply break the powder particles and size separation separate out the powder particles according to their size. Next we'll see. So size reduction is also known as comminution. Sometime question asked in the MCQ type question, which is another term for size reduction. So first term for size reduction is comminution. Next, size reduction is also known as diminution. These all are similar terms which are similar to size reduction. Size reduction is also known as pulverization. These all three terms are nothing but a size reduction process. All are same. Sometime question asked in the MCQ type question, which of the following is a another term for size reduction? So they will give you any one option out of these three. So you have to select the correct option. That is either comminution, diminution, or pulverization. These all are similar term for size reduction, similar term to size reduction process. We'll see how to carry out size reduction. Which are the different techniques of size reduction process? So size reduction you can carry it out first by either by using precipitation technique. By precipitation of powders in the form of fine particles, you can carry out the size reduction. So how you can carry out the size reduction by precipitation technique that we'll see. So suppose I have coarse powder particles like this. I have a powder sample which consists of coarse powder particles. Again, this is polydisperse. So coarse powder particles I have. Now this coarse powder, suppose I have to convert it to fine powders with the help of size reduction process. So what I will do in precipitation, what I will do, I will just dissolve this powder. I will dissolve this powder in a suitable solvent. So now I have solution. So I have to select a suitable solvent for this where this powder is completely soluble. So now I have solution of the powder where all powder particles are dissolved. Now next process what I will do, I will add this or simply I will inject this solution in a one more liquid. In one more liquid, I will inject this with the help of continuous stirring, either by using magnetic stir. So the solution which I had prepared in step number 2. In first step, I have coarse powder particles. In second step, I have prepared the solution by dissolving in a suitable volatile solvent or a suitable solvent where the powder is completely soluble. Generally, volatile solvent is preferred because it completely evaporate. So later on, this solution which I have prepared in volatile solvent, I will just inject with the help of fine needle in one more liquid which is a non-solvent for powder. Means in this liquid, your powder is insoluble. That's why this powder can precipitate. So just inject the solution of powder in volatile solvent which I had prepared. Inject this solution in a suitable liquid with a continuous stirring. Which liquid I have to select? Which is a non-solvent. So during continuous stirring, what will happen? The solvent will evaporate. This solvent will evaporate and you will get fine powder particles. So you have to carefully control the rate of injection. By carefully controlling the rate of injection, you will get a fine powder particles. How? By simply evaporation of volatile solvent, that is solvent number 2 here, solvent which I had used in second step. So solvent will evaporate and The drug is your powder or powder drug is insoluble in this solvent because I have selected non-solvent. So that's why due to evaporation of solvent this solvent will evaporate, and due to insolubility of powder in the second liquid, which I have selected non-solvent. So powder is insoluble. So due to continuous stirring and insolubility, the powder will precipitate out. So simply I have converted the coarse powder particle into fine powder particle by precipitation technique. One more technique you can better way utilize for conversion of coarse powder particles into fine powder particles, that is by using different mills, that is by mechanical process. The mechanical process for powder particles breakdown, that is size reduction. This mechanical process we have in our syllabus. But you must know how you can convert the coarse powder particles into fine powder particles with the help of precipitation. Also, in precipitation, quickly we'll see. In precipitation, suppose I have coarse powder, so what I will do for conversion of coarse to fine, I require two liquid. First liquid is a solvent for that particular powder, generally volatile, and second liquid, that is non-solvent. So I require two liquid for precipitation of the coarse powder into fine powder. So I have coarse powder particle. Now I have converted into fine powder particle. So what I will do? I will dissolve this coarse powder particle in solvent first. So I will get solution here. And now this solution I will inject in a one more liquid which is non-solvent. So as this liquid is a non-solvent for that particular coarse powder, so what will happen? The evaporation of solvent takes place because solvent is volatile. So solvent will evaporate and the powder forms a precipitate or precipitate in non-solvent. So this is simply a precipitation process of the size reduction. In simple way, you will get it. So just we have to dissolve in a solvent. Later on, we have to add in non-solvent with continuous stirring. Evaporation of solvent takes place and powder precipitate in the form of fine powder particles. This is simply a precipitation process of size reduction. Now we'll see one more process which is utilized in commonly utilized in pharmaceutical industry for size reduction, that is by utilizing the mechanical process. So which is the mechanical process of size reduction. So here in second technique which is commonly utilized for size reduction in pharmaceutical industry, that is mechanical process of size reduction. In mechanical process, what do we do generally? Here we utilize a different equipments for size reduction which is known as mills. So mills utilize the energy. For what purpose energy is utilized? Energy is utilized for breakdown of powder particle. So with the help of energy, the powder particles are break. These coarse powder particles convert into fine powder particles by utilizing different mills. So which mills commonly utilized in a pharmaceutical industry? So in mechanical process here simply the mills are utilized. How mills break the powder particle? By utilizing energy. So here energy is utilized for breakdown of powder particles. So which are the common mills utilized in pharmaceutical industry? First is hammer mill, next ball mill, next cutter mill. Initially it is used especially for cutting of herbal uh, uh, fruit drugs, especially like bark, branches, roots. Then fluid energy mill, then colloidal mill. So these are commonly utilized mill for particle size reduction. These are all things we have in our syllabus which we will cover in next subsequent lectures. So in mechanical process, the powder particles are break with the help of mechanical energy. By applying the mechanical energy is applied with the help of different equipments, and these equipments are commonly known as mills. So where the actually size reduction process is utilized in pharmaceutical industry, size reduction process is utilized for breakdown of powder particles. And for pharmaceutical industry, we require drug as well as we require excipient. Especially majority of the drugs are majority of the drugs are solid in nature. So the drugs are basically coarse powder particles, and these coarse powder particles are break into fine powder particles with the help of size reduction process. In addition to this, we require excipients also. So excipients are added in the pharmaceutical formulation for various purposes. So these excipients are also available in the form of solid powders, and these powders are break with the help of size reduction process. So drug as well as excipients, these are utilized for especially solid dosage forms, like which are the examples of solid dosage forms. For example, conventional tablets, then capsules, then pellets. These dosage forms require powder as a raw material, powder drug as well as powder excipients. Next, pow- powder is also one of the dosage forms. For example, dusting powder. Here also powder drug, powder excipients are required. Then for preparation of ointment also we require a drug, and drug is generally mixed with the ointment base. Then for paste also. So these are few examples of dosage form which require a drug as well as excipients which are in the powder form. Next, for preparation of solution also, we require a drug as well as excipient. Both are available in the powder form, and these both drug as well as excipients are commonly dissolved in a common solvent, and later on volume is make up with the help of vehicle to get a solution type dosage form. So all dosage forms require drug as well as excipients, and these drugs as well as excipients are break down into fine powders with the help of size reduction process. In addition to this, the herbal dosage forms, which consist of the different drugs which are obtained from natural origin. For example, from different medicinal plants. So, different medicinal plants, different parts of the medicinal plant, like leaves of the plant, roots of the plant, branches of the plant, these are collected from natural source. And later on, these leaves, roots, branches or barks of the medicinal plant, these are not directly utilized in a pharmaceutical formulation. Instead of that, suppose I have collected branches of the medicinal plant. So I will not utilize these branches directly. So what I will do, I will first of all cut these branches into different pieces like this, and later on I will again do the size reduction to get fine powder of the branches. So this is first important step before preparation of formulation, herbal formulation. So the different parts of the medicinal plant which are collected from natural source, these different parts are first of all reduced to fine size with the help of size reduction process. So size reduction utilized in a herbal formulation also. In allopathic formulation as well as in herbal formulation requires a size reduction process. That's why it is very much important topic that we have to discuss in pharmaceutical engineering. Next, we will see the next point, that is how you can carry out size reduction. So, which are the different techniques of size reduction? First is crushing. So, here powder material is crushed by applying a compressional pressure on the powder material. In between two objects of the mill, the powder material is crushed, like or in roller mill, the powder material is crushed. Then cutting with the help of sharp blade, sharp knife, the uh, different parts of the medicinal plant are initially cut. So as we discussed earlier, suppose I have the some branches. So what I will do first, I will first of all cut into different pieces, and later on I will do next subsequent size reduction. So cutting is also mechanism of size reduction. Even this mechanism also we utilize at our home also for cutting of the vegetables, cutting of the fruits. So cutting of the vegetables, cutting of the fruits is nothing but a size reduction process where a coarse material is converted into fine material. Then pulverization. Pulverization means to make a fine powder. Here also this mechanism is also utilized. And shredding. Pulverization means to make a fine. A coarse material is converted into fine with the help of different mills like hammer mill pulverization. Then shredding. Shredding is carried out with the help of shredders. This shredding is also utilized. We utilize at our home. Shredding is carried out with the help of different shredder. For example, this is shredder which consists of fine orifice, and powder material or a coarse material is first of basically rub on this shredder to get a fine powder particle. So shredding is utilized in pharmaceutical formulations also, preparation before preparation of pharmaceutical formulation. For example, shredding of cocoa butter, which is utilized in suppository. So cocoa butter is utilized as suppository base. So cocoa butter is first of all shredded with the help of shredder to get a fine powder particle. Yes. Next, we'll see. Now we have discussed how to carry out the size reduction process. Now, next is a objectives of size reduction. Why we have to carry out size reduction? In size reduction, what we do, we just break the powder particles. How you carried out size reduction, the different processes also we have discussed. And now next important thing, why we have to carry out size reduction. So the objectives of size reduction, that this objective must be very much clear so that you can better way understand why size reduction process is important in pharmaceutical industry. So one by one we'll discuss. Size reduction process produce the powder particles of narrow size range. Already we have discussed. Coarser powder particles, polydispersed powder particles convert into narrow powder particles. So narrow size means small size powder particles we will get. So why narrow size powder particles we require, especially for mixing purpose. So drug as well as excipient. Drug and excipients, these are mixed to get a dosage form. For example, suppose I have to prepare a dusting powder for topical application over the intact skin. So what I will do simply, I will just reduce the size of drug, reduce the size of excipient, and later on I will mix it with the help of suitable mixing equipment, suitable mixer. So I will get a dusting powder. So mixing is one more important pharmaceutical operation, and mixing, effective mixing is required. Why effective mixing is required? To achieve the content uniformity of drug in a dosage form. This is quite new concept for you, concept to you. We'll discuss what is meant by content uniformity. Content uniformity means exactly same quantity of drug in a same quantity of powder dosage form. This is applicable in all dosage forms. Let's say for solid also, liquid also, as well as semi-solid also. So exactly same quantity of drug should be there in a same quantity of dosage form. And this is nothing but a content uniformity in very simple terms. So mixing of drug and excipient is required. Effective mixing is required to achieve the content uniformity. And this effective mixing you can carry it out if you have narrow size powder particles. If you have narrow size powder particles, then better way you can mix it and content uniformity can be achieved. We'll see with the help of example how size reduction helps in achieving content uniformity and what is meant by content uniformity in detail. So suppose I have to prepare a dusting powder at industrial scale. Suppose I have to prepare 1 kg of dusting powder. 1 kg dusting powder I have to prepare, which contain how much concentration of drug? 1 kg dusting powder suppose contain 10% drug. How much is the quantity of drug in a dusting powder? 10 kg of drug I have to add in 10% of the drug in 1 kg. So how much is the 10% of 1 kg? 10% of the 1 kg means 100 gram. Means 100 gram of drug we have to add in how much kg of powder? In 1 kg of powder. Means 1 kg powder contains how much drug? 100 gram of drug. So now simply what I will do, I will just mix 100 gram of drug with excipients, then you will get 1 kg powder. Now this 1 kg powder is 1 kg dusting powder. Now next important thing. So in 1 kg of powder I added 100 gram of drug and the remaining quantity of excipients later on I will get a dusting powder. Now next important thing here we have to discuss. I will not pack this 1 kg of dusting powder in one container. No. 1 kg of dusting powder I will not pack in one container. Instead of that, what I will do simply, I will divide this dusting powder according to the pack size of the container. We'll see. So now I have 1 kg of dusting powder ready, which contains 100 gram of drug, means 10% of 1 kg. It is 100 gram. So now 1 kg of dusting powder I have prepared, and this 1 kg of dusting powder, suppose I will pack in a different containers according to the size of container. Let's see. Suppose I have to pack 100 gram of dusting powder in one container. In one container, I have to pack 100 gram of powder. So 100 gram powder per container. So how many container I will get for 1 kg powder? For 1 kg powder, I will get 10 containers. Right? So 1 kg powder, dusting powder, I have to pack in a total 10 containers. So I will make 10 parts. 5 containers, 6, 7, 8, 9, and here are 10. Container number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now I have made 10 containers. And in each container, how much weight of powder I have added? 100 gram of powder. Now, this 100 gram of powder should contain how much drug? 10% of 100 gram is 100 gram of powder should contain 10 gram drug. Right? Because 10% of drug I have added initially in 1 kg powder. Similarly, in 100 gram powder also 10% of drug should be present. So 10% drug initially I added it in 1 kg. So now 10% drug should present in 100 gram. So 10% of 100 gram is 10 gram. So 10 gram of drug should present in all containers. So here 10 gram drug must be there. Here also 10 gram. Here also 10 gram. There also 10 gram. Likewise, all containers must contain 10 gram drug. This is known as contained uniformity. This is known as contained uniformity. What is mean by contained uniformity? Contained uniformity means exactly same quantity of drug in the same quantity of dosage. So I have taken 100 gram of powder in each container, and each 100 gram of powder should contain 10 gram of drug. This is known as contained uniformity. Suppose I have not mixed the drug and excipient properly, then what I will get? I will get in, suppose I in first container I will get 12 gram of powder drug. Second container I will get 15 gram drug. Third container I will get, let's say, 20 gram drug. Fourth container, let's say, I will get 10 gram drug. So here non-uniform drug in containers. Quantity of drug in all containers is not uniform. This is non-uniform. See, in first container 12 gram, second container 15, third container 20, fourth container 10 gram. This is non-uniform distribution of drug in a container. So this is non-uniformity. याला काय म्हणायचं? This is non-uniformity. And when you will get non-uniform distribution of drug, if the mixing is not proper, and that's why proper mixing is required to achieve the contained uniformity. And contained uniformity you will get if the mixing is proper, and the mixing is proper if the powder is drug as well as excipients are available in narrow size range. And that's why size reduction is important. Now, based on this example, I hope you must have better way understood the what is mean by the size reduction and why size reduction is important for content uniformity. Very much important. Next, second, in case of suspension time dosage form, why fine powder particles are required? Basically, to reduce the rate of sedimentation. Now, what is meant by suspension? Suspension is a biphasic dispersed system. It consists of two phases. Which are the two phases? Solid powder particles, dispersed phase, and these are dispersed in a suitable liquid medium like this. So, dispersed phase, powder particles, dispersed phase. Suspension is a biphasic, which it consists of two phases. Which are the two phases? Dispersed phase and dispersion medium. These are two phases in suspension. So, why fine powder particles are required? Dispersed phase means drug. Dispersion medium generally water is used. Consists of excipients. Why fine powder particles of drug are required? To reduce the sedimentation. What is mean by sedimentation, that we'll see. Now, suspension means you must have understood, you must have prepared suspension in first year practicals also. So suspension is basically biphasic dosage form. It consists of two phases: solid particles, that is dispersed phase, and liquid medium, that is dispersion medium. Now next important thing. During storage, what happen? Again, I will draw the diagram of suspension. So initially, I have dispersed all powder particles in suspension. So during storage, what happen? Under the influence of gravity, gravitational force which is acting from downward, under the influence of gravity, what will happen? These powder particles will settle at bottom slowly. So initially, all powder particles are uniformly distributed throughout storage, but under the influence of gravity, what will happen? Powder particles settle at bottom like this. Few powder particles settle at bottom and few remains in a dispersion medium. This downward movement of the powder particle during storage, now this is known as the particles which are concentrated at bottom of the container is known as sediment, and the process of the downward movement is known as sedimentation, and this is one of the instability of suspension. Suspension is said to be stable if all powder particles are uniformly distributed throughout the dispersion medium. If during storage powder particles settle at bottom and forms hard cake at bottom, which is difficult to redisperse on normal shaking of container, suspension is said to be a unstable suspension. So that's why, in order to minimize the instability, the rate of sedimentation should be less. Sedimentation should be takes place in slow manner. So sedimentation must be slow, and this sedimentation rate you can determine with the help of one law, which is known as Stokes law. Stokes law is utilized to determine sedimentation rate. So according to Stokes law, we'll see the equation for Stokes law also. Stokes law gives you the rate of sedimentation. So sedimentation velocity is equal to d square rho 1 minus rho 2 into g, means gravitational force, divided by 18 into eta. This is the equation for Stokes law. So v means sedimentation velocity, v means velocity of particles which settle at bottom, and the sedimentation velocity is directly proportional to d. D means diameter of powder, dispersed phase, powder particles. Okay, particles of dispersed phase. So, based on this equation, what we understood, the velocity of powder particle is directly proportional, sedimentation is directly proportional to diameter. Means in short, if the diameter means size is more, the V is more, and quick sedimentation of powder particle takes place, means powder particle will immediately settle at bottom, and which is responsible for instability of suspension. That's why to make a stable suspension, the V should be less. How you will get less sedimentation velocity? If diameter is less. And how you will get less diameter? Which powder particle size? Less size you will get by using size reduction process. And that's why size reduction is important. This is second important objective of size reduction. Next, size reduction process increase the surface area of powder particle. The surface effective surface area. Which surface area? Surface area. Effective surface area. This effective surface area depends on what? Depends on particle size. Particle size. And the surface area is inversely proportional to particle size. That we'll see. So surface area, effective surface area is inversely proportional to size of powder particle. That's why if the size of the powder is less, surface area is more. Okay, and if surface area is more, we'll see with the help of equation. Okay, here only we will see surface area depends on size, that we have understood. If you have fine powder particles, then surface area is more. Here we will see. more surface area. How you will get? By reducing particle size. If you reduce particle size, means if you break the powder particle, the surface area will be more. And more surface area means more dissolution rate according to Lorenz-Whitney equation. So by increasing surface area, you can increase the dissolution rate. And how you can increase surface area? By reducing particle size. So this relationship is given by one equation, and the name of the equation is modified Lorenz-Whitney equation. Modified modified Lorenz-Whitney equation. Modified Lorenz-Whitney equation. According to this equation, dc by dt is equal to d a k k w by o, means partition coefficient, water oil partition coefficient, divided by v into h, cs minus cp. This is the equation, modified Lorenz-Whitney equation. dc by dt is rate of dissolution of the drug. It is directly proportional to a surface area. Means if the surface area is more, the dc by dt, means the rate of dissolution dc by dt is also more. So what is the equation for rate of dissolution? Rate of dissolution means dc by dt. So dc by dt means rate of dissolution, means in simple words, amount of drug dissolved, that is concentration of drug dissolved, divided by time, dc by dt. So if the more amount of drug dissolved, then numerator will be more. In less time, means time will be less, then dissolution rate will be more. We'll see. If surface area is more, the rate of dissolution is more. Rate of dissolution is more means what? According to modified Noisy-Whitney equation, what we have discussed, the rate of dissolution is directly proportional to surface area. Okay, the equation we have discussed so far. Now, now we'll see what is mean by more dissolution rate. More dissolution rate means more dc by dt. More dc by dt means what? Which one will be more? Numerator will be more or denominator will be more? Numerator will be more. More dc and less dt. Means time required will be less and more concentration of drug dissolved. Then only you will get more dissolution rate. Means in short, more dissolution rate means less time required for dissolution, and less time required for dissolution means in short it is fast dissolution. Fast dissolution. So fast dissolution of drug you can achieve by increasing surface area. Surface area, how you can increase? By reducing particle size. And how you can reduce particle size? By process known as size reduction. And that's why size reduction is important. I hope you have clearly understood. Then in pharmaceutical dosage form like in capsule, the powder material, drug plus excipient, these are filled in a shell, gelatin shell, as well as HPMC shell. So in capsule we require fine powder particles. Of course, why? Because after administration of capsule, the powder particles between drug and excipient are released in GIT, and for quick dissolution, we require more surface area, and more surface area how you can achieve? By reducing size. So powder, if you have less particle size, the fast dissolution will take place. Next, for dry powder inhalers especially for management of different disease conditions associated with the respiratory tract. For example, for management of asthma, we require a dry powder inhaler. The powder is packed in a small size capsule, and later on it is inspired through mouth in the respiratory tract, and later on This dry powder inhaler release the powder in a respiratory tract. So powder should reach where? Respiratory tract means powder should reach at alveoli, and powder will reach at alveoli if it has less size. Size contributes in aerodynamics, and that's why mass median aerodynamic diameter. This is one common diameter which is actually utilized to check the efficacy of dry powder inhaler. So the size actually governs the where the powder particle will deposit, and powder should deposit in a deep lung, that is in alveoli, and this can be achieved if you have the fine powder particles. Then ointment also which is applied on the skin, paste also which is applied on the skin, both require a fine powder particle to reduce the irritation. If you have a coarse powder material, let's say coarse with a sharp edge, coarse and sharp edge powder particles I have, these powder particles after topical application, after rubbing on the skin, cause the irritation. And that's why to minimize the chances of irritation, we require fine powder particles. So coarse powder particles cause the irritation of the skin. To minimize the irritation, we require fine powder particles. Next, small powder particles with narrow size range are responsible for better flow of powder. This is especially applicable for solid dosage form like tablet capsule. So, in uh, for preparation of tablet capsule, we require sophisticated equipments, tablet compression machines, and powder must have proper flow properties, proper flow behavior. So, a flow is uniform when if we have small powder particles. And that's why for uniform flow, we require small powder particles. A uniform flow of powder particles, especially for preparation of tablet and capsule, is required to reduce the chances of weight variation. Means suppose 1,000 tablets are prepared in one batch, all 1,000 tablets should have nearly same weight, and this is known as uniformity with respect to the weight and less weight variation. And less weight variation, the variation should be less, and this less weight variation you can achieve by uniform flow, better flow. And for better flow we require small powder particles. Next, again especially for herbal drugs, we extract the herbal drugs from different parts of the medicinal plant, and for extraction the size reduction is important. Suppose I have the branches of the herbal as a medicinal plant like this. If I extract this directly, the yield will be less. Why? Less yield. Why? Because reason is more size. Size is more, surface area is less. Instead of that, if I convert this into fine powder particle, and later on if I perform the extraction, if I extract it with the help of different solvent, the yield will be more. Why? Because fine powder particles I have. So more yield is due to more surface area. So for extraction of different herbal active constituents from different medicinal plants, we require size reduction. Because solvent should penetrate. For extraction, we utilize a solvent. Solvent should penetrate deep inside that cellular level. And this deep penetration is possible if I have more surface area. And that's why particle size reduction is important. Next, come to the mechanisms of size reduction. How you can carry out size reduction? First, by cutting of the material. Next is compression. Next is impact, attrition, and combination of impact and attrition. Combine attrition and impact. All mechanisms we have to discuss in detail. Especially these mechanisms are asked in the semester examination. First is cutting. As such, name suggests cutting means here material is cut into a small pieces with the help of sharp blade or knife. So here this mechanism is specially utilized for the different parts of the medicinal plant. Suppose I have collected branches of the medicinal plant. I will not directly subject it to make it fine. Instead of that, what I will do, I will just cut with the help of different sharp blades or knives. So that I will get different pieces. And later on, these pieces I will subject to size reduction with the help of different mills to get a fine fine powder material like this. So in cutting mechanism, the material is cut into different pieces with the help of knife or blade. So here simply a force is applied on the material with the help of sharp knife or blade on most important thing on narrow area of the material. How to apply the force on narrow area means what? Application of force on the narrow area of the material means what, that we'll see. Suppose I have collected branches like this. Now where should I cut first? Narrow area means here should I cut. Then only I will get a fine pieces like this. I should not cut here. I should apply force on narrow area like this. So that I will get fine pieces. So here force is applied on narrow area of material with the help of different sharp blades or knife results in cutting of material. So which equipment is utilized? The force is not applied manually. Instead of that, the equipments are utilized to increase the production yield. The mills are used, which is known as cutter mill. This is widely used in a for breakdown of the herbal medicinal plant for cutting, especially different parts of the medicinal. Let's say bark for wood, then for branches, the cutter mill is used. This material, this mechanism is used for which material? For roots, branches, barks, peels, for all the cutting purpose. We require the cutter mill, and the mechanism is cutting. So you can see this is the mechanism. Here, this is the knife, this is knife, and this is the material. So material has cut into fine pieces with the help of cutting mechanism, and the equipment is cutter mill. Later on, next mechanism is compression. What is mean by compression? That we'll see. So in compression, the material is crushed by applying pressure. So here, suppose I have a roller mill which consists of two rollers like this, and very narrow gap is exists between two rollers. These rollers move towards each other. So here, from here, the material is loaded in the mill. So what will happen? These two rollers apply a compressional pressure here and results in a breakdown of the material like this. So here you will get product. From here you have to load the material. So in compression, just a solid material is crushed or compressed by applying pressure with the help of heavyweight rollers. So roller mill is utilize the compression mechanism. Now construction mechanism working of roller mill we'll see in next lecture. It consists of two heavy duty rollers, and the material is compressed between the two heavy duty rollers, results in a breakdown of the material. Next is impact. What is meant by impact? Impact means the here we have two different conditions. We'll see in impact. Here, first important thing, a stationary solid particle. Particle is stationary, is not moving, and this particle is hit by moving object of the instrument. So, suppose I have hammer wheel. It consists of hammers like this, sharp blades, and this hammer wheel continuously rotates at high speed rotation, rotates at high speed. So, if the particle comes in contact with the hammer wheel, what will happen? This high speed rotation of the hammer wheel results in what will happen? This high speed hammers hit on the hit the powder particle. Means basically, if I have powder particle and this is hammer, so this hammer hit the powder particle and results in a breakdown of the powder particle. This is first condition. Or second condition, moving solid particle strike on the stationary object of the wheel. This is especially in case of fluid energy wheel, where powder particle moves at high velocity. This is powder particle. This powder particle move at high velocity, high speed, and in between we have stationary object of the equipment. So this high velocity powder particle strike on the stationary object. This object is stationary, not moving. Particle is moving particle or mobile particle. Particle strike on the stationary object and results in a breakdown of the powder particle into fine particles like this. So due to high velocity of powder particle, powder strike on the stationary object of the mill, and due to the collision between the powder and the mill object of the mill, the breakdown of the powder particle takes place. Next come to attrition. Attrition involve again two things: collision between two high velocity particles. Suppose I have first high velocity particle like this, second high velocity particle like this. These two particles collide with each other like this and results in a breakdown of the both powder particles. So here particles strike on each other results in a breakdown. First thing, or second, particles are break into fine size by two stationary objects. This is especially applicable in ball mill. So this is the inner wall of the chamber of the ball mill, consists of stainless steel balls like this. So this is also stainless steel ball. In between the wall of chamber and the ball, the material is crushed by the moving balls. So this is also known as attrition. So attrition again, pressure is applied on the solid material by the stationary object, that is your chamber of the ball mill and rotating balls. Next come to factors affecting on size reduction. First factor is hardness of material, next is toughness, stickiness, moisture content and density. This is very much easy. One by one we'll discuss. I said based on the name also you can understand the which how factor affect on the size reduction. First, hardness. Hardness is the characteristic property of the material. If the material is hard, too much hard, then it creates a problem. Of course, in the size reduction we require more energy. So if the hardness of the material is hard, then of course we require more energy for size reduction process. And for the more energy, we require a specialized mill for size reduction. So hardness is measured with the help of one scale. We'll see in subsequent slides and the different range of the hardness with respect to their characteristic that we'll see. So if the material is brittle material, which is easy to break, so if the material is brittle material, then we require less energy. And if material is hard material, then we require more energy, of course. Hardness is measured with the help of one scale, and this scale is Mohs scale. So, if the hardness of the material, we'll see the values and characteristic. If hardness of material is less than or equal to 3, then this material is said to be a soft material. When the material is said to be a soft, if its hardness is less than or equal to 3, then soft material, these materials are very easy to break with the help of even fingernail. With the help of fingernail also you can break the powder particle if the powder is soft, means which has hardness less than or equal to 3. If it is in the range of 3 to 7, then it has intermediate hardness. The powder is said to be have intermediate hardness. Intermediate hardness, which is also easy to break, and it is ideal especially for milling purpose, for size reduction purpose. If it is more than 7, hardness is more than 7, this material is said to be a hard material, and for this material we require special mills for size reduction. So for hard material, means if hardness is more than 7, for these mills, for this material we require special mills with sharp blade for size reduction purpose. If the material is hard, if material is soft, you can easily break with the help of fingernail. You can see here. And if it is 3 to 7, it is ideal for side reduction. That is intermediate hardness. So intermediate hardness, already we have discussed. What is my intermediate hardness? If the hardness is 3 to 7, which is known as intermediate hard material, and this material is good for size reduction, which can also easy to break by applying less energy. Toughness. Toughness is also creates a problem, especially a soft material, but if it is a tough like a rubber, then it is very difficult to break. And for such tough material, sometimes material is soft, but it is tough to break. So for tough material, again we require specialized mill. Majority of the time, the different parts of the medicinal plant, let's say bark, branches, roots, these are also tough. Why? Because it contains a moisture collected from natural source. So it contains moisture, and that's why due to presence of moisture, moisture is present in the different parts of medicinal plant, and this moisture is responsible for toughness. And if the material is tough, then it is difficult to break. Then how you can solve this problem? By removing the moisture. Moisture must remove. If you reduce the moisture, then automatically toughness you can reduce. Material you will get dry material which is easy to break. And how you can reduce the moisture? By subjecting the material to dry. So the different parts of the medicinal plant after collection, these are first of all dried with the help of different dryers, and later on these are subjected to size reduction. Why? To reduce the toughness and moisture content. Stickiness, especially sticky material. If material is sticky, then what will happen? It creates a difficulty in size reduction. Why? Because sticky material stick to the parts of meal. After addition in the mill for size reduction, what will happen? The sticky material stick to the inner walls of mill, and after sticking, they may choke the mill, they may block the mill. This is also a problem with respect to the sticky material. So, which are the common example of sticky material? The gummy natural substances like different gums, which are utilized in pharmaceutical formulation as a emulsifying agent, as a thickener, as a stabilizer. Then different mucilages, which are obtained from different seeds, which contain polysaccharide. Both contain polysaccharide, and both are sticky in nature. So, such sticky material creates a problem in size reduction. So, size reduction of such material is difficult. Why? Because these materials stick to the inner walls. They may choke the meal, they may block the meal. And how you can reduce the stickiness? By complete drying. So these materials also subjected to the drying first, and after drying, these are subjected to size reduction. Again, to prevent the chances of choking of the moisture content. Already we have discussed moisture content. Moisture content influence the hardness. If material contains moisture, then it is quite soft. If it is hard, if contain moisture, then it is tough. The material is sticky also if it contain moisture. That's why it is advisable to remove the moisture. And how moisture is removed? Moisture is removed, or moisture content is reduced by drying of the material. Complete drying of material is required. If you remove the moisture, material will become soft. Material will become less sticky, and it can be easy to break. Moisture also influence the flow properties, because if the moisture is present in the powder, that results in a formation of dump mass, and this dump mass may choke the mill. That dump mass may adhere to the inner walls of mill, and that's why it is advisable to remove the moisture before size reduction. So dump mass, as we discussed earlier, see dump mass attached to the or adhere to the blades of the mill, inner walls of the mill, different components, and that may choke the mill. So how much moisture content usually acceptable? Less than 5% moisture content is acceptable or suitable for dry grinding. Okay. If moisture is present, sometimes it is subjected to wet grinding also. But if it is a less than 5%, then you can easily do the dry grinding of the material. Then next, last factor is density of material. So what is meant by density of material, that we'll see. Density you can calculate by using this formula, mass per unit volume. Density directly affect the output of the mill. How you can see? If the material has a more density means more mass, more weight, and which occupy less volume. When you will get more density, the numerator must be more and denominator must be less. Then only you will get more density. Such material are known as heavy material. या material काय म्हणायचं? Heavy material. So these material, heavy material occupy less volume, and exactly opposite. If density is less means numerator is less and denominator is more. So mass is at numerator, so mass is less and occupy more volume. So such material are said to be a light material. Why? Because these powders are light powder. Light powder means these powder occupy more volume and with less weight. Means even if you take a less weight of powder, because of less density, these are less dense powder, so this powder occupy more volume. So these density values also affect on the size reduction process by affecting output. How, that we'll see. If the density of material is more, means more density. So more density means more mass. Already we have discussed more mass and less volume. Volume is less and mass is more. And if due to less volume, this powder occupy less volume, and due to less volume, more and more amount of powder you can load in the mill. And if you load more amount of powder, automatically more product you can, more product you will get. You can't load more output. Output of mill is more. You can load more powder in the mill, and automatically product output is also more. Basically, means due to less volume. Volume is less, that automatically you can load more amount of powder in the mill, and you will get more product. Exactly opposite, if the density is less, less density means less mass and more volume. So these powder occupies more volume because these are light powder, occupy more volume. So you cannot load more powder in the mill. Why? Because these powders are light powder. More volume, this powder occupy more volume. So you cannot load more amount of the powder in the mill. So less output of the mill. Output will be less and less product, less powder material you can load in the mill. That's why which powder is suitable for uh, better size reduction? The heavy powders. Heavy powders. Heavy powder means more density. More density means more output. So such powders are suitable for size reduction. This powder with less density means light powders. Light powders are not suitable for size reduction. These powders are not suitable because product output is less. So this is up to the factors affecting on size reduction process. Next subsequent lecture, we will discuss the remaining parts. Thank you.